Hello friends, welcome to TechNipoints. In this video, we are going to learn about two things. First one is Coroutine Scopes and another one is exception handling in Coroutine. So let us move towards first topic, that is Coroutine Scopes. So until last video, we have only seen the global scope which covers all application in its scope. But there are other scopes also which are helpful when we understood how they work, how they are, if they are life cycle aware of, and what are their specific advantages of using them. So before adding those, we first need to add the dependencies. So let's open Google and you can search like coroutine lifecycle dependencies, and you can just click on the first result that comes as an official Android developer guide. So from here you can copy these two lines. Let's open build.gradle here and we'll paste here as an implementation. Okay, there is near version also available. So let's first copy this first one. This one is for view model and this one is for lifecycle scope. So let's include this as well here. Mm, Let us see what's the latest version and upgrade to them on this 2.6.1. Yes. And we click on sync now. Yes, Gradle skin sync is complete, and now we can use lifecycle scopes and other scopes in our Android application. So let's move towards main activity, and here we have already seen this global scope dot launch. But the problems happen with this global scope is that if we are switching between one to another activities or multiple fragments inside our Android application, then and if you are not using whatever the resources, whatever the calculation or whatever the network calls we are making in their first activity, and we are still using global scope for that, so there will be a loss of resource and might be called as memory leak. So to avoid this, we can use other scopes like lifecycle scope and view model scope like this. So let us simulate this example and I'll show you how the resources are wasted using global scope. We can create a repeat function here with okay, let's create a while I haven't given any condition here, it's just a true, and we'll click make a delay here. That delay will be of 1 second, 1000 millisecond, and we will print in the log that coroutine running. Okay, and here I have created a one button here in the activity main. So on click of this button, I have also created a second activity here. It just named as, just says that the second activity, and I have will try to switch from one activity to another and see what happens with the coroutines. So find view by id button dot id dot open next activity dot set on click listener, and here we'll open second activity. Did this and second activity class.java, and now start activity passing this intent. Okay, okay, I'll write finish here, so that after the second activity has been launched, first activity will be destroyed, and we'll see if it affects anything for the global scope. Now let's try running our app and open our logcat. So this coroutine has started running. After 1 second of delay, it is printing coroutine running, coroutine running. Okay, and I click on this button and the second activity has been opened. But even though second activity has been opened, we are still able to see the coroutine is running. Let's expand with the locket, and here you can see the difference here in the seconds, that for every second is 39, 40, 41, 42 here. For every second it is still running. It means that coroutine is still running. So this might create a memory leak and also use a lot of resources in the background. Let's say we are making some network call in the main activity, and if we switch to the another activity, and that network call didn't completed, but still we are at the second activity and we don't need that network call now. Still it is running and consuming the resources and ultimately draining the battery. So this is the bad programming practice, and this is the most disadvantage for using the global scope. For that, Kotlin has provided some other scopes that are feasible and we can use them according to our requirement. So there is one scope, that is lifecycle scope. So let me do one thing, close the app, and let's replace this global scope with the lifecycle scope. We are getting the lifecycle scope according to the dependency we have just added. So this lifecycle, let's first see and then I'll explain how this lifecycle scope works. I have just replaced this lifecycle scope and then click on run button. Open the locat, and again coroutine has started after delaying 1 second. And now I click on this button to launch another activity. Okay, another activity has been launched. And now if you have noticed here, the coroutine is no longer running. It has been stopped. Why? Because of this lifecycle scope. We have just changed it here. Because whatever the coroutine scope we have created here, that is only tied to the specific activity. This lifecycle scope does these things. This this lifecycle scope makes these coroutine scopes tied to its parent activity in which it is launched. So currently this lifecycle scope has been tied to this main activity. So, and that's why once the scope of this main activity has been entered, the coroutine is automatically cancelled. So in short, what this lifecycle scope does, that it creates this coroutine scope and ties it to its lifecycle of its parent in which it is launched. So in this case, it is an activity. This works the same way for the fragments as well, even though fragment had different lifecycle. Once that once the module in which it is launched has been ended, the coroutine cancels itself, saving the resources, and also this stops the memory leaks. So that's why life cycle scope is always preferred over the global scope. Also, we have introduced one dependency earlier, like this is view model called view model.ktx. There is a dependency is for view model scope. Like this life cycle scope, we also get view model scope, but we'll not get it here, we'll get it in view model. So it is very much similar to this one. It is just like it will tie to that specific view model and it will exist as long as the view model exists. So I am not able to create here separate view model and show the all the steps, but it is completely the same. It has also specific purpose, but it is just that it is specifically made for the view model. Now, let's move towards another topic that we are going to discuss in this tutorial, that is exception handling in coroutine. Now, in the coroutine, let's say if we have one coroutine here, the launch block, and let's log one message calling one API 1. Okay, and let's say this API throws some type of exception. Throw exception. Okay, and let's say there is try catch block we have implemented to catch this exception. E colon exception. and we'll again log here the message that exception caught. Okay, now let's try running if this works as we want. It will be exception generated and we think it should be caught here, or it's relaunch the application and oops, it crashed. Let's see what happened here. Calling API 1 has been executed, but this exception has thrown, even though we have here included the try catch block, but it still didn't caught by this catch block. Why? Why did it happen? Well, the catching on code routines handled the different way. Exception caught way is not similar to whatever we do at other places. Well, what happens? Let me explain here. Inside some coroutine, we have here global coroutine as lifecycleScope, and inside which we have the ability to launch the multiple coroutines nested inside them each other. There is no limit. We can list any number of coroutines here. But let's say if our API calls makes an exception here, that exception comes here, and that exception, if it is not directly handled here, it gets propagated to the above level of exception, and here the exception goes out of this coroutine, and here it is not handled. We haven't handled any mechanism here, and it throws at the main thread and making our program crash. So how about if we cover this one directly in the try catch block? Let's say if this thing is making exception, then we can do this directly. There is no need of nesting, right? Okay, so that will work. Let's try running again our application, and yes, our application has now survived. We can also see the message here, exception code, calling API 1 and exception code. Though this works, but this is not the best way while working with the coroutines. And if the API makes some exception, then let me show you the another recommended way to catch the exception in Kotlin coroutines. So some exception handling mechanism has been already given by coroutine. That is, let's say we can declare it as file handler equal to coroutine exception handler. We get here is a context and here is one throwable, and we can define all the code here after calling the exception. What we have to do, this is basically a catch block. We can say here we can execute the code which we want to do after the exception has been caught. So let's we'll move this line exception code towards here, and now remove this try catch block from here. There's the need of here, and let's add one more block here, and let's nest it on one more hierarchy. Okay, we will not throw exception here, and we'll just call the API to here, and we'll just call API 3 here, calling API 3. Okay, these three blocks has now been declared here, and now let's try doing the things this exception, and let's see if we get. But before we start, we have to install this exception handler into this global scope coroutine. So we'll install this by in its parenthesis, but if we have already here dispatchers, so we can use the plus operator here and put the handler here so that both of things will work. And now try running our application, and let me clear the logcat first, and then I'll again relaunch the application. Let's see in the logcat. Okay, and the exception has been caught without the try catch block here. And this is the nested hierarchy. Here there is a one lifecycle scope.launch, which is a global big coroutine, inside which we have again launched one small coroutine. Inside the small coroutine again we launch even small coroutine, and inside which the exception has been generated. But still it has been propagated from this launch block to this block to this, and this launch block to this global scope. And this global scope has the handler exception handler installed, and this it handled the exception, and the compiler came into here and it printed here the exception code. So we are able to call API 1, 2, 3. These 2 and 3 were independently working on their own in their respect to coroutines, but whatever the exception had been generated in the API call 1 has been caught, and we have executed the body of the exception handler. So that's how we can handle the exceptions in the coroutines. Now I would like to show you one more thing. Let's replace this lifecycle scope with some coroutine scope. Basically, the coroutine scope is the same function like others, which can initiate a coroutine block here, and inside which we can make the asynchronous operation like everything else I have just explained in the previous videos, but it just differs in some context. That was the difference. I'll show you here. Okay, I have just replaced this lifecycle scope with this Kotlin scope, and the launch came here. And let me make some modifications here. Let's remove this nesting. So all this coroutine will start simultaneously now. This coroutine will start after delay of 1 second, and this API call 2 will start after delay 2, and this API call will start after delay of, let's say, 3 seconds. Let's create them as 3 and 5 seconds. Okay, now everything else is same. I have just here replaced the lifecycle scope with the coroutine scope. I have just added the delays here. Nothing specifically changed. Exception handler is same as it was. It still has the exception here, and it will throw and catch the exception here. So I'll open the logcat here. Okay, logcat is already empty, and I'll relaunch the application here. Okay, the application has been launched, the exception has been caught as the application have crashed. But what we can see here, coroutine 1 has started calling API 1. Okay, it started API call, it caught the exception, and exception has been caught by the exception handler. Here exception caught, we can see the message here. But what about other coroutines which are parallelly started? Because we have already seen that if the independent coroutines are there, they can start all at a time. But okay, if it has a delay, then it will start after 3 seconds. This one will start after 5 seconds. But they didn't start it at all. We didn't see any message calling API 2 and calling API 3 from this one. That means these coroutines haven't been started. That means they must have been cancelled. Well, CoroutineScope does these things. CoroutineScope has the specific functionality, or you can facility, you can say, that once if the one coroutine fails, that is throws an exception, it cancels all other coroutines and none coroutines will run. Even if we can throw exception through the second one, it will do the same. It will execute the first one if we get the result for first one, and it will start executing. It will parallelly execute all the coroutines. But if let's say it had launched 10 coroutines, but out of 10, if it got exception at the fifth coroutines, then all the other coroutines which are yet to finish will be cancelled automatically. So this is the different behavior provided by this coroutine scope. But what about if we don't want this behavior and want other coroutines also to start keep running even though one coroutine fails? Then we have this scope, separate scope for that. That is a supervisor scope. So supervisor scope avoids this behavior of coroutine scope. Let's see. Let's move all these three blocks, coroutine blocks inside this supervisor scope, and they all are here now. Let's clear the logcat and relaunch the app again. Okay, the application has been started, and we can see here we are our API for we are started calling our API. Exception has been thrown and exception has been called, but it doesn't have any effect on the other coroutines. Another coroutines are still turning. It is one API second is called, API third is get called. So this supervisor scope avoid this behavior of the coroutine scope, and the other coroutines will continue to execute even though one coroutine fails. So I think that is enough for this video. I have covered both of the topics. First one is a different coroutine scopes, and another one is the exception handling mechanism in coroutines. And I hope that are both clear to you. And if it is not, you can please let me know in the comments below. I will try my best to explain those. If you like this video, then please like, subscribe to this channel to keep me motivated to uh, do more on my content and to improve it for you. And if you have some doubts, then please let me know in the comments. And if you don't like something about this video, then please let me know that also in the comments so that I can improve on my content better. Meet you in the next video tutorial with some another interesting topic. Till then, goodbye, happy coding.